Hello and greetings. We are from Group 6 and we like to present the Hopfield network and its case study. We are consist of 5 members, starting from me. My name is Faraliana. Then we have Meg Dineva, Ashkin Fatia, Amira, Farhana and Ainul Karya. So the content for the topic, starting from introduction to Hopfield network, energy function and memory recall, Hopfield network training algorithm, real-world application of Hopfield networks, and last but not least, advantage and limitation of Hopfield networks. So today I will introduce everyone to Hopfield networks. A Hopfield network is an artificial neural network that helps us to recognize patterns and remember things. It was created by John Hopfield in 1982 and it is inspired by how our own brain works. So, the main purpose of a Hopfield network is to store and recall patterns or memories. It's like having a memory bank that can help us to remember things we have seen before. So, one cool thing about Hopfield networks is that they can recover patterns even if they are damaged or missing some parts. They do this by finding stable state to converge to. The architecture of a binary Hopfield network includes of a group of binary neurons connected by synaptic weight. The number of neurons in the network is usually the same as the number of elements in the pattern that we want to store or recognize. To sum up, a Hopfield network is a special kind of neural network that helps us to remember things and recognize patterns. So, the network that has fully connected neurons that are either on or off and it works in a recurring way. So by understanding the architecture and how it works, we can use Hopfield networks to solve complex problems. Now I will pass the floor to the next person, Meg Dineva.
Thank you, Farah, for your introduction of the binary Hopfield network. Next, I will be explaining about the energy function and memory recall of the network. So the energy function of the network is defined as the negative 0.5 times the summation of the synaptic weights multiplied by the product of the binary states of the neurons. So the energy function formula is important to capture the interaction between the neurons in the network. The synaptic weights, which is denoted by Wij, between neurons indicates the strength of the network connections, while Xi and Xj will take values of either plus, as either positive one or negative one. So the energy function has the aim to find a state with minimal energy function, which will indicate the stable patterns of the network. The energy function will determine the stability of different states in the network and guides the iterative updating process. And lastly, the iterative updating process will continue until the lowest energy is found, which is very desirable for this network. Next is the memory recall of the network. So the Hopfield network has an associative memory that allows patterns to be associated and retrieved based on their similarity. After training the network, patterns are stored as a stable attractor states in the network. So when a partially or noisy pattern is presented to the network, it converges to the closest stored pattern. And the retrieval process is achieved by iteratively updating the network states. Previously, I had mentioned about the synaptic weights in the energy function formula, and in here we will use the synaptic weights between the neurons in the network to enable the recognition and completion of the partial inputs. The network acts as an auto-associative memory by recalling complete patterns based on incomplete cues. So finally, this type of memory will enable patterns recognition and recall learned information. That's all from my part. Next, I will be passing to Ashikin.
Hi, I'm Ashkin. Today I will explain about Hopfield network training algorithm. We start with simple analogy. Imagine there is a group of 5 friends, A, B, C, D, and E. Assume there is an activity was planned. Not all members can come. If the member can come, we consider he is active or state 1. If the member is busy, we consider it inactive or state 0. Those who always active together will have stronger bonds since they see each other more frequently. Thus, friends with stronger bonds will affect each other's decision the most. if your best friend comes to the event, there is a high probability that you will also come, right? It's same as this Hopfield network. At the top left, there is a set of numbers based on each friend's activity. First column for friend A, second column from friend B, and so on until the last column for friend E. So there is 4 rows of number indicating 4 different events. So we can see that from the yellow highlighted box, every time friend A is active or in state 1, friend E will also active. And also every time friend A is inactive or state 0, friend E also the same. This shows that friend A and E have developed very strong bond and affecting each other activity. So same also can be seen from friend C and friend D. Only in the third event that their decision is different. The rest is all the same. So their bond is pretty strong, but not as strong as bond between friend A and E. So, if we have our fifth event with 3 friends already give their answers, as in the number show, 1, unknown, 0, and unknown. Can you guess from the numbers that friend C and E will come or not? So now we go for the real explanation. There is 6 steps in this algorithm. It is first initialization, which is we just set 0 or small random values to all of the neurons. Second is pattern training, like the numbers in the box. We train the network with few sets of number to indicate each neuron active or inactive. And third, based on those neurons' value, we will update our weight. Those line between neuron, that is the weight, the connection. We use Hebbian rule, which is stating that the weight increases every time both neurons have same state as in the training pattern. Like I said before, the friends always see each other together, then their connection becomes stronger. And for the step number 4, diagonal element setting. Diagonal element is the arrow that coming from the same number and going into the same number, like W11, which means that that is the weight of the neuron number 1 to himself. We need to set this to 0 to avoid the neuron from affecting its own value. It's like friend A is talking to himself and then make his own decision, brainwashing himself. Then for the 5th step, iterative updates. Repeat step number 2 until 4 until our weight converge, which means the weight changes is smaller than the predefined threshold. And lastly, we retrieve the output from the given partial input.
In the real world, the most common application of this network is image restoration. When images are corrupted by noise or damage, this can distort the visual information, making it extremely difficult for us to analyze and interpret the images accurately. However, we can leverage the network's ability to reconstruct missing or corrupted parts of images and restore its clarity. As you can see on the slide here, we have 2 original pictures, one of Bugs Bunny and a squirrel. The photo of Bugs Bunny has been degraded using salt and pepper noises, whereas the photo of the squirrels have been cut in half. By applying the Hopfield network, we can reconstruct the images and it seems extremely similar to the original images. So how do the network achieve this? The first thing is we have to train the network using a set of both noisy and noise-free images. In the architecture, it consists of interconnected neurons. These neurons represent each pixel in the images, and during the training phase, the weights of the connection between neurons are adjusted to learn the patterns of noise and noise-free images. To remove noises from these 2 pictures, we first feed the noisy images into the network, and then the network will iteratively update the state of its neuron based on the learned patterns until it converges to a stable state, which is the output is the restored images, and the noisy pixels have been effectively reconstructed. Thank you.
Now, we will discuss the advantages of using the Hopfield network. Firstly, it is easy to train. This is due to the weight soft connections between neurons that can be adjusted to store and recall the pattern. Secondly, it is robust. The network can store and recall patterns even when some neurons are inactive. Lastly, it is fast as it can store and recall patterns quickly. Next, we will highlight the limitation of the Hopfield network. The first limitation is the Hopfield networks have a limited capacity for storing patterns, typically being able to store only a small number of patterns reliably. Secondly, when a Hopfield network stores a large number of patterns, the accuracy of recalling those patterns decreases. This can cause error and false association when trying to retrieve the stored information. Lastly, Hopfield networks use connections between neurons that are symmetrical, meaning they have the same strength in both directions. This symmetry restricts the network's ability to learn and represent complex patterns that have asymmetrical relationships, which limits its effectiveness in handling certain types of data. Now we will look into the possible future developments and improvements of the Hopfield network. Firstly, enhancing the capacity of the Hopfield networks to store and recall a larger number of patterns reliably is a significant area of improvement. This would allow them to handle more complex and diverse datasets. Lastly, by allowing for asymmetrical relationship, Hopfield networks can better model and represent complex patterns found in the real-world data, improving their applicability and effectiveness.